Right, hello everyone, welcome to POLI Fórum. This is our POLI Fórum on energy transition. I'm Professor Gustavo Assi. It's my pleasure to host you today. And as you can see today we have a POLI Fórum in English, since we have one guest speaker, Professor Toru Sato from the University of Tokyo. Thank you for coming.
My pleasure.
And also with us, Professor Silvio de Oliveira Jr. from POLI. Thank you for coming as well.
Thank you for inviting me.
Wonderful. Well, today our topic is on decarbonization of offshore systems or offshore operations, right? Everything we do at sea for the offshore industry. And as you know, in Brazil, as well as in Asia and the Gulf of Mexico and in many places, offshore industry is equivalent to oil and gas exploration. And we understand the offshore industry is going through some transformations. We're moving from hydrocarbons-based industry, perhaps targeting an energy, sustainable energy industry in the future. And this climate change plus energy transition scenario brings new ideas, new challenges for us from the offshore industry as well. So I have my personal view of how the energy transition will transform or even revolutionize the offshore processes. But I would like to hear from you first, in your impression, from your experience working with the offshore industry, first with oil and gas, now moving on into new processes. Where do you see that the offshore industry is going? Are we going in the direction of energy transition to sustainable energy, or are we going in the opposite direction, holding on to oil and gas and giving up any transformation from an energy transition point of view? I would like to start with Professor Sato, please.
Okay. I think the speed to change to the renewable energy world depends on America.
It depends on America.
Yeah,
Good point.
Trump.
Yeah.
He said that he needed oil and gas and dig it, right? So, but that doesn't long, right? So we need to change to the clean energy world, at least at the end of this century.
Right.
So, particularly, but in Japan, we have to think about the nuclear, how to treat the nuclear power, right? Because we had an accident in 2011. So many people don't like nuclear, but the industry people, they like nuclear because it's cheap. So then at this moment, Japanese government, they're thinking to make the seventh fundamental law of the fundamental plan of the energy. So every 5 years, they make the energy plan. So then the newspaper said that we'll increase. At this moment, we don't have much, maybe 1 or 2 nuclear plants. Then the government is thinking to make it more 20% of the total, energy. So then after that, we have after rest 80%. We share the oil and gas, particularly gas and nuclear, renewable. Okay. So the renewable energy includes photovoltaic and also the ocean wind turbines, right? So ocean wind turbine is the main cause of the renewable energy in Japan. Right. And also we still use gas. So CCS is necessary to reduce the CO2. That's the Japanese plan. So that's the vision of it 2050. Then after that, we have to increase renewable, particularly offshore renewable, including offshore wind power, floating offshore wind power. Then also the OTEC, so and also the wave energies and so including everything.
So you're saying the main view is providing more energy. Right? And in Japan, that means getting rid of nuclear and bringing more energy from the ocean, since Japan is basically getting its energy from the ocean.
Oh yes, right? Yes.
Silvio, in your view, perhaps comparing to Japan to the Brazilian scenario, how do you see this vector driving the transformation of the offshore processes?
Well, I think first the oil and gas industry, they are very conservative in terms of changing the technology. Given the political situation in the world, we're going to move to an energy transition, but with a very low speed. In fact, we have already some technologies that could be used to supply power demands. For instance, using combined cycle. Also, we can think about oxy-fuel gas turbines. Mainly, if you connect the idea that has been discussed lately, such producing hydrogen in offshore conditions. If you think about an oxy-fuel technology, using oxygen, which will be, let us say, a part of the production in the electrolysis-based production hydrogen, because we have, for instance, we can use the seawater to produce hydrogen, and by using electrolysis, we will produce also oxygen. And this oxygen could be used in an oxy-fuel power plant. And maybe another idea that can be explored is to use hybrid power hubs by combining conventional technology such as gas turbines that combine on cycle with wind turbines. And also, as you mentioned, using OTEC, which is when we can use the temperature gradient that we have in the sea water. So we can also think about putting a Rankine cycle, for instance, using ammonia to, let us say, complete part of the requirements of power demand for supplying these demands of FPSOs, for a given set of FPSOs. And in any case, I think this transition will be conducted in a very low speed, unfortunately, because of course some technologies must be developed, but part of them are already available. But as I mentioned before, the petroleum and gas industry are very conservative in terms of changing radically the technology basis of production.
So do you think in terms of the speed of the transition, this will call for regulations or, for example, public policies to drive faster this transition, or this should be something just led by the market of energy, for example?
I think if you let all the market laws, they will never change the technology.
Because it's cheaper to produce energy from hydrocarbons.
Yeah, of course. All the technologies I mentioned, like wind energy and OTEC, for instance, they are not yet competitive with gas turbines. Of course.
So it calls for a regulation from another
aspect? I think mainly the regulation of the CO2 emissions.
Is that the same?
Well, I agree with him because the energy demand is increasing a lot. Because
and always will be, right?
Yeah, of course, but
more than the
acceleration.
Right.
Because we have the data center now. AI will be
requires a lot of energy.
Yes, so that's why we need a data center. Then we need cool places to keep the data. So to do so, we need air conditioning, and so we need a lot of energies, electricity. So that's why still we need oil and gas. That's one thing.
Right. But from what you said and what you complimented, in Japan, I understand everybody's concerned with CO2 emissions from everywhere, driven by science data, and public policies are trying to be built on top of that if it's a good public policy, right? In Japan, perhaps the need to change from nuclear to other sources is a stronger driver than CO2 emissions. In Brazil, perhaps CO2 emissions will be a stronger driver than the transition. Now, Let's think about what we do at the moment, the processes that the offshore industry operate at the moment. For example, we do a lot of oil and gas extraction from offshore reservoirs, and then this mixture comes up to the topside facilities where it needs to be separated. Well, you spend a lot in this offshore transition would be reducing the impact or becoming more efficient in the process that we already do at the moment. So in your opinion, what would be the first things to tackle in terms of substitution, upgrade, replacement? What are the new processes that could replace the existing processes in the offshore industry, in your view?
Well, after you.
Silvio, you
Well,
begin, please.
I think first we have to improve the efficiency of all kinds of processes. This is, I would say, the first measure that we can or we should do when we are trying to reduce emissions. Is to increase the efficiency.
To do better what we already do.
Yeah, that's it. I think this is the first step. Depending on the company, they have been developing this kind of procedures. For instance, waste heat recovery. This is a very important
Waste
issue.
heat.
Waste heat.
We waste a lot of heat
Yeah.
in our processes.
Yeah, this is the first, let us say, activity. For instance, we can recover part of the waste heat linked to the gas turbines. That it's already they use it. We can separate petroleum just using part of this waste heat. But we probably can recover a little more by using what we call ORC, organic rankine cycles, to generate a little more of electricity to supply the demand, so that we have to move the compressors, pumps, and so on. Combining technologies, for instance, as I mentioned, using hybrid systems to generate power. Another aspect is to produce, let us say, new products, thinking about the production of hydrogen and the substance that can carry hydrogen, like ammonia, like methanol. This will, let's say, introduce some well-known processes, but in another operating conditions. An offshore hydrogen plant, an offshore ammonia plant, an offshore methanol plant. Is it possible to have hydrogen carriers, for instance? That's it. Will you use the conventional process to produce hydrogen, like the steam reforming process, or are you going to use an electrolysis plant?
Mm-hmm.
Of course, we are thinking, I would say, long time frame for thinking about that.
Okay.
Okay. But first thing first is to improve the energy efficiency of all the process and trying to use available energy that we have, for instance, in the ocean, like the ocean thermal energy conversion, or what is called the BEST, which is buoyancy energy storage technology, which is to use the buoyancy effect in order to store energy, and after that we can produce electricity by letting let's say, a balloon to going up by the buoyancy effect. So these are some available energy resource that we can think about using them to reduce CO2 emissions, for instance.
Right, we come back to those solutions later on. But let me hear, Professor Sato, in your view, what could be changed from what we're doing right now?
Well, so one example is ship fuel. So they are IMO decided to zero carbon in 2050.
Yeah.
So then the Japanese shipbuilding companies, they are thinking to move gas first, then ammonia, then hydrogen. So they are thinking, reducing the oil and increasing the gas and from 2030 they'll change to the ammonia. So that's they have already their plans. So that's a big good example. And also the other society will follow, not follow, but they are thinking to change to the hydrogen world. So yes, but another aspect is doing things in offshore is expensive. So efficiency is very important, right? Carbon capture. So some Japanese companies are thinking to capture CO2 in a different way from the conventional, chemical method, chemical absorption method. So so that will be changed the CO2 capture industry a lot.
Right.
So and also the membrane technology, and that will change the technology for this capture CO2. So those kind of things can make a new business, right? So that's very important. If it is very expensive, not very, but some expensive, but still we can make a new business. So then that will change the world. Anytime if we can earn money, that's important to change the things. Otherwise, no one follow you, right?
Right. Yeah, you mentioned. I was writing down some keywords that you mentioned. So, for example, you mentioned nuclear, then wind energy, then OTAC, and wave energy, oxyfuel, hydrogen, combined cycle. So all these ideas, they are either tackling more efficient systems or more energy to drive new systems or new processes, right? We mentioned first perhaps to tackle is the efficiency of the existing systems or processes, still mostly based on oil and gas, but then in the future adding more processes to that, right? So this could be our short-term vision or the near future vision, doing better what we already do, knowing that we need to reduce our CO2 footprint on the generation of energy that we already have. Right. Now let's move on to a midterm future. So let's say in the next 5 to 10 years we have to improve efficiency and start to bring more renewable energy. In the, let's say the 23rd year time frame, right, passing the middle of this century, how do you see, or what do you see, what technologies do you see required for the offshore industry to tackle? Let's start with Professor Sato.
Okay, in 2050s or something, right?
Well, we hope to be neutral. Many industries are saying they will be neutral. Maritime transportation, Brazil as a country, right? They are all saying they're going to be neutral in terms of emissions. So what do we need to be neutral regarding the offshore industry by then?
Okay, innovation comes from, I believe the innovation comes from, the size of the industry. Okay, so many people are doing working for some special kind of offshore technology, then we can have a lot of innovations, right? So we need the people, many people. So to do so, we need an industry, large industry, right? So to do so, the government, target, number, figures are important. Government have to show the number, then industry can follow it. So otherwise, industry will hesitate to move to the new world. Like, for example, ship industry, in Japan, have to move to the floating offshore wind turbine industry, but they hesitate because government doesn't show the number, right? So that's important. Then, if the government shows the how many offshore wind turbines we built, then industry follow it.
You mobilize to prepare the power.
Yes, that's very important. So the government have to do it now. Then in 2050, we can make a big industry. So that industry change the world, so change the society. Then we can have a lot of innovations, and we can have the efficient technologies, and of course we have to prepare for that at this moment.
Okay.
But many technologies can grow in that situation.
Interesting. Yeah. Silvio, do you agree with that? How do you see the mid-century?
Mid-century
Yeah.
scenario. Well, in terms of power generation, I think that we're probably going to move to power hubs.
Power hubs.
Centralized power plant, which can supply the demand of, let us say, a given set of FPSOs, the flow production and storage systems that we have in Brazil. In the first step, I would say conventional power hubs based on gas turbines and steam turbines, with of course CCS systems,
Right.
in order to reduce the emissions, and also to put the CO2 into the wells, a kind of, I would say, conventional technology. Probably, it depends on the gas turbines industry. We can also have some gas turbines using mixtures of hydrogen and natural gas. And probably gas turbines using hydrogen, produced in offshore plants, for instance, based on electrolysis, using the seawater, probably. And I think a second step was to use a hybrid power with gas turbines and wind turbines, and probably all tech plants. That's it. And this could reduce the CO2 emissions, the specific CO2 emissions. Mainly this is the most important figure. But based on, let us say, conventional technology. We have already gas turbines, we have already wind turbines, we have already combined cycle technology, power plants, and also CCS technology. This could be put together in order to reduce the CO2 emissions, to improve the efficiency. That's in principle, this can be the most important feature of a given power hub. Instead of operating in every one FPSO, a given set of turbines that will work in a partial load operation throughout the life cycle of the plant, we could put a given set of gas turbines, steam turbines operating in a better efficiency operating conditions. This is the big idea of a power hub. And probably that's what we expect to have a lower operating cost than a given set of power of FPSOs operating with their own power plant. That's the idea.
Oh, that's kind of a paradox, right? If you, cost versus energy and efficiency.
Yeah.
There are strings pulling in different directions, right?
That's the challenge, yes.
For me, there's the very fundamental paradox of the offshore industry, in Brazil especially, is how can you decarbonize an industry whose objective is to extract hydrocarbons, right?
Yeah.
So there is a fundamental transition to be there.
That's right.
For example, in Brazil, the energy return over investment, the ROI cost, so the energy you put to produce energy from our offshore fields are about 15 to 1. So we burn 1 barrel of oil to extract 15 barrels of oil in our operations. So probably the first thing to tackle is to eliminate that 1 barrel that we burn in order to get the 15 out, right?
That's it.
So there is one chunk of CO2 emissions that we can reduce with technology we have at the moment, but implemented still in one hydrocarbon-based industry. And then in the mid-century, perhaps new energy sources will come.
We replace this. Yes.
To replace that.
Yeah.
Right. Now, visionaries. You're looking way ahead to the end of the century. Probably we won't be here anymore. But if you look all the way back, all the way ahead to the end of the century, of course, I won't say what is the future of the oil and gas industry, no, but what is the future of the offshore industry? I believe ocean resources will always will be there to be explored. So I can see the offshore industry existing or thriving in new ways by the end of the century. Perhaps not an oil gas based industry anymore, perhaps, I don't know, what is your vision? But if you could dream about a long-term future, how do you see the offshore industry or the offshore processes? What kind of process will we be doing by then? Or are we planning to be doing by then? Who wants to dream first?
Okay. The end of the century, I'm thinking, the energy, the fusion energy energy becomes in majority, kind of majority. Then of course we have the offshore wind turbines and also many renewable energies, but we probably fusion energy comes true. Then so in that case, then but still offshore industry is good because we can keep the nuclear energy or fusion energy offshore. So we need the floating systems. Japan doesn't have the oil and gas, right? So we don't care about oil and gas.
Yes, that's right. Yeah.
Then, but we have to import oil and gas at this moment and maybe in 50 years. But at the end of this century, probably we don't import oil and gas anymore. Then we move the fusion energy and the other energies, and still maybe we recover the nuclear again and also offshore energies. Then, but all these cases, floating system is really important. So the kind of conglomerate of the floating systems, like an island or something. So those kind of things becomes a good big industry, it's a big business.
Right. Silvio, how do you see this changing?
Let us have some dreams. First thing first, I have mentioned the importance of the efficiency of energy conversion. But if you move to for instance, natural resources, the values of the energy conversion efficiency compared to oil and gas, they are much lower. I mentioned the OTEC. If you choose a given OTEC plant, which will be working, let us say, between 4 degrees at the bottom of the sea and 25 degrees at the surface, the carbon efficiency is about 6 to 7%.
You need to move a huge mass of water to get a bit of energy.
Yeah. A real plant, we should have 2% of efficiency. But we don't have the problems of emission. We are using a natural resource, a free natural resource. The same reason we can use for conversion by using solar energy, wave energy, wind energy, let's say. So I would like that in the future we will get used to use this kind of resources. Because if you take any kind of what we call renewable energy, the energy density is much lower than a fossil fuel.
Yeah. But that's
because of the stored energy that we have.
Absolutely. That's a new paradigm of energy, right? I mean, our species, we learn to thrive and to evolve based on fossil energy, right? It's the cheapest, the most dense form of energy we could find available in nature. Now, we require a new paradigm of energy density, right? There's nothing compared to chemical energy of oil and gas, of hydrocarbons. But doesn't mean you could not find a new solution to your energy density, right?
And this implies that we have to change our way of living, because we use too much energy. We have a car with 2 tons of weight, and we drive a car like that. We spend gasoline or diesel, for instance, just to move, for instance, as I do, 7 kilometers to come from my home to here. And then people go to the academy, start making exercise by using the car. Okay, so the way we use energy throughout our lifetime is absolutely, it's not renewable, it's not sustainable. So if you try to really use a renewable source, we have first to change our way of living. Everybody has a cell phone. What's the density of energy that we have in a given cell phone? What's the density of knowledge that was spent to have a cell phone. And most of people use the cell phone in a very stupid way. Exchanging what's called fake news. That's a kind of entropy generation.
Energy waste. Yeah.
Energy waste.
Well, that is interesting. This goes far deeper than just technology. It goes into our morals and way of living, right? Just to give you a data, probably you know this already, but when I do my first class on energy transition for my undergrad students, first class, try to have an idea of how much energy we use as human beings. And how do you do that? So we do a simple calculation in the class. You can estimate the power of one human being. It's not difficult. Let's take one person doing some handwork for 8 hours a day. So that is the power you would have, average power for one person, right? Well, we use horsepower as a standard. So you could think of human power as one value of power. Right, so let's say you are like a caveman. You live way behind in a time when you could only rely on your own human power. So that is the only power source you have. You have to eat to produce your own power. That's you. Well, we don't live like that anymore, right? We use much more power than we can produce with our own body. Well, I use clothes that someone else produced, some other industrial processes. I came here by car. This is made of concrete. You know, we have a roof, there's air conditioning. So for my living standards, I use much more energy than I can produce myself, so much more power than I can generate. So if you calculate the amount of power that the world is producing, like the demand of power for humanity at the moment, and you divide by the number of people in the planet, you get an average of how much power one person is spending. Now comes the data. The way we humans, of course, this is an average. There's people who spend more energy, people who do not have access to so much power. But if you take an average, a human being in the 21st century is living as if I had 35 servants doing my work. 35. So this is the amount of power that I require to sustain my life in the 21st century. We demand 35 times the power that one person can produce in its own work, handwork. So we evolved to use, to demand a lot of power as a species, you know, to keep this standard of living. I'm not saying this is good, this is bad, this is evil, you know, the morality of that. I'm not going into this discussion, but just the gross number of how much energy we came to depend on as a species to evolve to these life standards we have, as if a caveman had 35 servants working for him. So this is the average estimate. So this is kind of surprising for us. When you say, I need to change the way of life, it's probably not going back to one person, one human power per person, no. But it's something more efficient or with less impact than 35 servants.
Let me ask you, the word power. You know, your power is just moving and force multiplied by time or something, or you know, the acceleration or something, because you know, the brain needs the power a lot,
and
right?
it burns a lot of energy. Yeah.
So that's really important. We eat food, the most part of the power is used in brain, right?
Yeah.
But AI will be the majority of the world. So which means that we don't need your brain, right? So that's why we don't need to eat so much. That will happen, right? So we don't need the 35 servants.
No, right? Well, now we're very far off from offshore technology. Right. Now,
just an example. Sure. About, I think it happens 15 or 20 years ago. That it was sold in Brazil, a kind of a Japanese ice cream.
Oh.
So we bought water that came from Japan by an airplane.
Yeah.
this is the example of this is not sustainable.
Yeah, we need to sustain that lifestyle,
Yeah.
so that requires a lot of energy.
Yeah.
Absolutely.
It was
Well,
very good, I think.
The calculate, the power or, is similar to the, footprint, right?
Yeah.
Carbon footprint. So, 1980s or to 1990s, some like, the WWF, wanted to spread, think of the carbon footprint or an ecological footprint, right?
Yeah.
So in the ecological footprint, carbon footprint can be calculated, which is energy actually. So if you use the energy, that can be calculated, CO2, amount of CO2, so that means that you reduce, the area of the forest. So that's the way to think about the CO2, carbon footprint. So it's similar way to think, right?
I think so, yeah.
Yeah.
There has to be one equivalent to measure that, right?
So Japanese people use, a lot of land, more than our territory.
Yes. If you convert that energy into land use, you get to that point, yeah.
Then my student calculated that it's proportional to GDP. Carbon
Absolutely.
footprint is proportional to GDP. So we import many things. So because we have the money in GDP. At this moment, no, but that in 1980s or 1990s,
Yes, a huge GDP importing.
yes.
And in one way, converting meaning that you would have had a much larger country than required.
Yes.
Yeah. Right, now to wrap up our conversation here, I know both of you work with technology, right? We're engineers. Professor Sato is an ocean engineer with a chemical engineering PhD. Professor Silvio also mechanical engineer, working with thermal systems and well, we're all processes engineers in a way. I would like to invite you to pinpoint, to choose one technology that you see as interesting or important, that you could give a simple explanation of how it works, how can it needs to be developed or improved for this transition that we talked about. For example, you mentioned CCS a couple of times, wind, floating offshore wind turbines, nuclear energy, perhaps offshore nuclear power plants. You mentioned hybrid systems, OTEC. If you could choose one piece of technology to say, okay, we need more development. This is critical, and I would like to see more investment or more development or more innovation in that technology, because that's key in my understanding of the whole thing. What would that be?
In 5 years?
No, in
in
this whole process that we talked. Perhaps could be the first one for the 5 years, but perhaps something that needs to be ready for the 30-year time, if you could choose one tech, for example, if you have a money grant to hire 15 postdocs, where would you put them right now to develop something disruptive for the future? Batteries, okay. Energy storage.
Yes, energy storage. Battery is one way, but there are so many other ways to keep the energy, right?
Mm-hmm.
So yeah, that's the important thing.
So you say energy storage, meaning that perhaps we will have an excess of energy being generated at some point from renewable energy, but we need to, the critical technology is to be able to store that energy in the near future.
Yes.
So you think that energy generation and energy storage are not encompassing in the same pace to be ready together?
They have to be at the same. They have to be at the same pace.
But do you think they are?
Well, there are so many ways, right? So we have the electricity batteries, and we are now at this moment one Japanese ship industry developing the ship with the batteries.
Right.
All batteries.
Fully electric.
Fully electric. No, they carry the electricity
Yeah.
using batteries, right?
Oh, I mean, the electricity is the product.
Yes, product.
It's just a battery floating to
Yes,
deliver
yes,
electricity from
yes.
one side to the other.
Because we moved to at this moment we are the Japanese government thinking wind power should go far away from the coastline. Means that we need a floating, right? Because Japanese seas become very steep,
very
So,
quickly, yeah.
Yes, that's why. So then, so if it is offshore, then you have to carry the electricity.
Right.
Of course, cable is one way, but that's expensive, and also we have a lot of the cables for the how to say the data transfer.
Sure, yeah. The fiber optic cables.
Yes.
Yeah.
So that's why we need another way. So that's ship. So that's one thing, and also we have a lot of other ways to keep the energy, right? So we'll make some of the hydropower. Then so we carry the water to the mountain.
Yes.
In the evening, right? That's another way. So anyway, so we need some kind of hydrogen one way. Hydrogen it's just a carrier of the energy, right? So that's another way.
Interesting. So you think batteries or energy storage is a key technology
Yeah.
right now? Yeah. Good point. Professor Silvio. in your
Well,
opinion?
as I mentioned before, I would like to choose the OTEC.
OTEC.
technology.
Yeah.
Why? The OTEC, I would say it's based on very classic power cycle. It's a ranking power
Just to
cycle.
explain, ocean thermal energy
And ocean
convergence.
thermal
That's
energy
OTEC.
conversion,
Yeah.
it's OTEC. In this technology, we use the difference of temperature that we have in the seawater. Typically 4 degrees at the bottom and 25, it depends on which part of the tropical area of the world, of the earth, 25 degrees. So we put a power cycle using this temperature difference, and that we can use this to produce power, electricity. Although it's, let us say, a well-known technology, the first plant was installed in Cuba in 1930, last century, with about 22 kilowatt of electricity capacity. And last week we had an international conference in Rio de Janeiro about OTEC, and we have a very interesting particularity of this plant. They operate with a very stable temperatures. So the plant can operate in let us say, in the stable efficiency conversion of energy. That's very interesting. We don't have to put the plant working in partial load. So it's quite important to supply a given energy demand. Of course, today it's not economic, in terms of economic availability, it's not even, it can be compared to a gas turbine, for instance. But a lot of development have been done. There are some of these plants operating in the world. We have in Japan 3 or 4 plants like this, in Hawaii, and there is a group in Brazil that's studying a plant probably to be applied in Fernando de Noronha. And I think in the next few years we have a plant in Canarian Island operating. Because this is another particularity. This kind of plant can be applied to supply island power demand. But given this kind of characteristics, we can use this to supply FPSO's demands also.
With a floating OTEC
With
system.
floating OTEC system, that's it. And we have, another interesting aspect is these plants have lower footprint than solar and wind power systems. So I think this would be a very good development in order to improve the use of these power plants.
Right. Well, as you know, Professor Sato is one of the members of the International Advisory Board of the OTIC, our Offshore Technology Innovation Center. Professor Silvio is one program director of the OTIC as well on the low carbon power program. We're very happy for your visit this time. Thank you. We're going to be 2 long days of meetings tomorrow and Wednesday. Thank you, and I'm sorry for that. And Professor Silvio also,
my pleasure.
yeah, wonderful. I appreciate that. Yeah. Professor Silvio also working with OTEC systems, also coming up in the OTIC portfolio as well. Right, to finish, tell me if I got this right. So, in your opinion, I wrote it down. Between many technologies that you mentioned, so wave energy, wind, floating energy, OTEX, nuclear, perhaps floating nuclear energy, oxyfuel, combined cycle, hydrogen, also other ways to carry energy in the form of hydrogen or liquid hydrogen carriers. This all comes into the transition of the offshore industry. But if you could select 5 steps or 5 stages for this transition, I would say first one is efficiency, more efficiency in the process that we already have. Second, fuel change, so changing the fuel of especially maritime transportation, using fuels with less emission to be produced or to be carried and used. Third, more energy from clean sources, so generating more renewable energy from the ocean by all means that you mentioned before. Fourth, novel processes that we do not have yet. For example, new ways to separate and store CO2, or new processes to combine molecules and produce other processes in the ocean. And fifth, this all will lead to new businesses. So perhaps new business models, new companies that will come to operate, not oil and gas based companies, but perhaps a CCS company or a hydrogen company, or new businesses should appear. So do you agree with my summary of 5? This efficiency, fuel change, more energy, novel processes, which will lead to new businesses.
Absolutely.
Yes.
Yes.
Okay, so I think this is a
Very good
summary.
synthesis. Very good synthesis.
Synthesis of our talk today. Wonderful. Well, thank you for your time, for sharing your experience. Thank you all for coming. We will have time for questions once we finish. But thank you who is watching us online. This is our POLI Fórum on energy transitions. We try to do this as often as we can, but we hope you enjoy. And if you have comments, please write them down. Hope to see you soon again. Have a good day. Bye-bye.
Good.
Thank you.
Thank you.
1 hour.